Welcome to clickmyproject.com. Let us see the title of the project. The title of the project is a low complexity congestion control and scheduling algorithm for multi-hop wireless networks with order optimal per flow delay. Let us see the abstract of the project. The joint congestion control and scheduling problem in wireless networks has been extensively defined in the most of the systems. Often, each user is associated with a non-decreasing and concave utility function of its state, and a cross-layer utility maximization problem is formulated to maximize the total system utility subject to constraint that the rate vector can be supported by some scheduling algorithm. One optimal solution to this problem is known to be the max weight back pressure scheduling algorithm combined with a congestion control component. Furthermore, significant progress has been made designing distributed scheduling algorithm with a provable throughput and lower complexity than back pressure algorithm. However, most of the existing works in the joining congestion control and scheduling have only considered the throughput performance metric and have not occurred for delay performance issues. Although for flows with congestion control, the throughput is often the most critical performance metric, packet delay is important as well as the practical congestion control protocols need to set transmission timeout values based on the packet delay, and such parameters could significantly impact the speed of the recovery when packet loss occurs. Packet delay is also important for multimedia traffic, some of which have been carried on congestion control sessions. There are two major issues on the delay performance of the back pressure algorithm. For long flows, the end-to-end delay may grow quantitatively with the number of hops, and the second one is it is difficult to control the end-to-end delay of each flow. To address overall problems, the proposed system introduces the giant congestion control and scheduling algorithm that can achieve both provable throughput and provable per flow delay. The proposed system consists of three components: window-based flow control, virtual rate computation, and the scheduling. Here, the main idea of the proposed system is the end-to-end delay of flows. First, by using the window-based flow control, we can tightly control the number of packets inside the network. Second, by using a virtual rate scheduling algorithm with the computed virtual rate as input to schedule the packets. We do not wait to packets further accumulate before making the scheduling decisions. Let us see the flow of the project. At first, we should start the program. Here, the nodes should be created. In the wireless network, we are going to use the nodes for the communication purpose. The nodes should be created initially. We can generate more number of nodes to communicate each other with the packet transformation rate. So, the problem in the wireless network is the congestion control and the delay. To reduce that, in the proposed system, we have been used the window-based flow control and a virtual rate for the calculation. Here, at first, the packet should be transmitted is chosen, then the packet is transmitted among the nodes to the destination node. So first the source node chooses a packet to transmit, splits according to the size of the packet, then it initializes the window as 0, then initially it should mention the window size for the packets. Here always the packet size, here always the window size should be greater than the number of packets to transmit in the network. First, it should check the acknowledgement for the previous packet is received or not. If the acknowledgement for the previous packet is received, then only we can send the packet in the network. Otherwise, we cannot send the packet in the network. So, this is the window-based flow control technique. In the window, each packet is sent according to the queue size. So, otherwise, if the node sends the packet for the first time, that is, this is if it is the initial node, then it should not need any acknowledgement for the previous packet. So it should send the packet to the network. Then the scheduling is applied to the network. Here the scheduling is applied according to the link weightage of the nodes. Each link can be has its own weightage. So the link represents the distance between the two nodes. So the medium can handle only small number of packets. So if we give more number of packets than the medium size, there will be congestion control occurs. So the traffic occurs, then the delay will be occur. So to reduce the traffic delay and the congestion, we should analyze the link capacity and then we should schedule the packets according to the link capacity of the node, so only we can achieve the better performance. The packet sent to the destination node, the destination node will send to the acknowledgement for the source node. Here the packet may contain the header and payload informations. So here the header information shows the source and destination details, and the payload represents the data of the packet. When the packet is received at the destination node, it immediately sends the acknowledgement for the source node. The acknowledgement can be sent as the same path which the packet has been received already. So the acknowledgement is sent source node. Here the acknowledgement is received by the source node, then only the source node injects the next packet to the network. So likewise the source node injects every packet in the network if and only if it receives the acknowledgement. Let us see the demo of the project. First here we should choose the file which is going to transmitted according to the network. So the file here chosen should be splitted according to the size defined by the user. To select a text file, we should click the open button. Here we can choose any one text file. So the size of the text file is 1.88 KB. We click the open button. So the content of the source is displayed here. We should mention here the splitting size. So we give one, that is 1 kbps, and click the split. Here it contains the two packets. The file size is 1.88 KB. Here we have given the splitting size as 1 kbps, so only it has been splitted as two packets. Here the number of packets to send has been shown. Then we should click the next button. It will show the nodes. So the nodes in the network has been shown. Here we are going to use the 10 nodes. The source and destination node has been shown. Then we should click the next button. We should specify the window size. The window based flow control has been applied in this form. So here we have two packets to transmit. Then we should mention the window size more than the size of packets in the hand. So the window size can be more than 2. We should mention the window size as 5. When we click this button, we can get the number of packets to transmit. When we click the show button, it will show the window and the corresponding packet. So here packet 1 and packet 2 are in the queue. So at first the packet 1 has to be sent. When we click the current packet, it will show the first packet to transmit. In the queue, the first packet is in the first place. So we should click the next button. Here we should assign the link capacity for the each nodes. Here we have used 10 nodes, so the links are in between the nodes has been 10. So each link capacity has been assigned manually. When we have completed assigning the nodes, we should click this button to see the number of nodes. Then we should click the source as node 1. Then we should click the virtual date. So the virtual date is calculated according to the formula. When we click the scheduling, the normalized virtual date and link updation should be displayed here. When we click the calculate, the normalized virtual date and the link updation has been shown. So here this is the link updation. So each link can be sent averagely 3 packets for the time. If there are no sends more than 3 packets, there should be occur congestion. To avoid the congestion, we have determined the link updation. Then we should click the next button. When we click the get packets, it will show the number of packets to transmit. When we click the enter the packet 1, it will inject the packet to the network. So the packet has been transmitted according to the nodes. So when the packet is received to the destination node, it will show the packet received message. When we click this node, it will send the acknowledgement to the source node. So when the acknowledgement is received, we can see the acknowledgement received message. Likewise, as the same way, we have to send the second packet also. When we click the enter packet 2, the packet 2 also sent according to the network. So the destination receives the packet, the data received message has been shown. When we click the destination node, it will again send the acknowledgement to the source node in the same path. When the acknowledgement is received, we can see the acknowledgement received message. Then we should show the graph. Here the graph represents the time for the long flow for various hops. In the x-axis, it has been shown the number of hops for the source to destination, and the y-axis shows the time to reach the destination. So the time delay has been reduced and throughput has been increased. Thank you.